The IMAP, the Interstellar Mapping and Acceleration Probe, is set to launch. It's going to explore the very boundaries of our heliosphere. To learn more about this project, we're joined by David McComas, the mission's principal investigator. Thanks for joining us, David.
Yeah, thanks so much for having me.
And you mentioned that NASA is going to be launching 3 new spacecraft headed towards the special spot in deep space called the Lagrange point. Can you tell us more about these missions?
Yeah, sure. So there are 3 missions. The prime mission is my mission, the Interstellar Mapping and Acceleration Probe, or IMAP. And 2 ride shares are going along. One is SWIFO, which is a NOAA mission dedicated to do space weather. And the other one is Carruthers, another NASA mission that's designed to look back at the Earth at the very outermost boundary, outermost layers of the Earth's atmosphere. That extends all the way to sort of halfway to the moon. So 3 very exciting missions, all sort of working together to help us understand space weather much better.
Fascinating stuff. Can you tell us more about you mentioned the Carruthers mission. What's that going to be measuring, and why is that important for understanding space weather?
Yeah, so it measures the glow of hydrogen atoms, which have had the electron strip, so protons. Those are out in space, and they're sort of loosely bound by the gravity of the Earth. We haven't had a good picture of those really since the Apollo era, when we used to take pictures from the moon. Now you have to be very far away, and at the Sun-Earth Lagrange point L1, which we'll be at, which is about 4 times further away than the moon, you actually have a very good view of this surrounding space around the Earth.
And these missions are going to be observing space weather. Hear me out. What happens if they get hit by a solar storm or something like that?
Well, we're designed for that. You wouldn't send a hurricane airplane, a regular airplane into a hurricane. You design for the mission that you're going to do, and our spacecraft are designed to survive these sorts of harsh radiation environments from solar storms, and they're designed to measure what's coming towards the Earth. This Lagrange point, that's about 1 million miles sunward of the Earth, is a place where you have about a 30-minute warning before the solar wind that's coming out gets from that point all the way to Earth. So you can send radio waves back very quickly, and you can say there's this big storm coming, there's a lot of energy in the storm, and then you can predict that to some extent what's going to happen on Earth.
And you guys, or I guess NASA, is going to be sending astronauts to the moon with its Artemis program. How does space weather and understanding stuff like that, why is that so critical for human space flight missions?
Sure. The radiation in space storms is dangerous for humans, and so being able to predict it, knowing when it's arriving, even if it's only half an hour and ideally even longer before that, allows you to get the astronauts into safe locations in their spacecraft or underground at the moon and places where there's protection. Another really important aspect of it comes out of the IMAP mission, which is another type of dangerous radiation in space comes from outside the solar system, from the rest of the galaxy. Exploding stars, novas, and supernovas make very high energy particles called galactic cosmic rays, and those are coming in all the time. It turns out about 90% of those are shielded out by the interaction of our sun's solar wind and the local part of the galaxy, and IMAP's actually directly measuring that interaction.
And IMAP and the other satellites launching on this ride share will be placed in a special orbit 1 million miles from Earth. Why was that spot chosen?
Yeah, so it's about 1 million miles towards the sun. The sun's 93 million miles away, so it's about 1% of the way towards the sun. The sun is so much bigger than the Earth and has such stronger gravity that this point, the L1 point, only 1% of the way there is where the gravity of the big sun and the much smaller Earth are exactly equal. It turns out that point goes around between the sun and the Earth as the Earth goes around the sun, always staying upstream of the Earth, and it's very easy to stay in orbit around that gravitational null point. And it gives you this great 30 to 40 minute warning for space weather before it arrives at Earth.
And I'm looking here, the IMAP has looks like 10 cutting edge instruments on board. Can you give us a sense of what some of those are going to be doing, or if you've got a favorite one, we'd love to hear that.
I love all my children equally. There are 10 great instruments that are measuring different things. The 5 that are specific to space weather are measuring ions and electrons over a very broad energy range and magnetic fields. And with the ions, electrons, and magnetic fields, energetic particles, you're able to see all the different sorts of particle radiation that comes off from the sun.
Fascinating stuff. Always love sending more technology up into space to help us out. Where can our viewers learn more about this mission, Dave?
Yeah, so you can go to the websites. There's a website from NASA. I think it's /sun, and it talks about all three of the missions. You can also go to princeton.edu, imap.princeton.edu, which has a lot of material about the IMAP mission.